All right, now we have seen how to analyze our statistical data using ANOVA, analysis of variance, and its version of analysis of covariance and cover. Note that ANOVA is used um, when we have independent variable, or let me just start with dependent variable. Just one dependent variable, only one dependent variable, but this dependent variable may have more than one levels. Example is our case, which is pre-test mean and post-test mean. It means it is just performance score. That is only one dependent variable, but that dependent variable, that performance score, has two variables. First variable is pre-test, and the second variable is post-test. So, and it has more than just one or more than one independent variable. And this dependent variable may have more than one levels. Example is the gender. Gender has female and male. You may have a school name. We had the school A, school B, school C, like what, like whatever, right? So you have seen that we may have only one independent variable here, or you can add more dependent variable there. All right. Now, what will be the difference with multivariate analysis of variance, which is MANOVA? For MANOVA, we have more than one dependent variable. It means these dependent variable are different. Let's say it doesn't matter on levels, but these variables are different. Example is when you have performance and income. Let's say student performance and their parents' income. Okay, you see, performance is just one dependent variable. It doesn't have any level. And income is another dependent variable, and this dependent variable doesn't have any level. And the same thing as the ANOVA, it may have one or more than one independent variable. All right, so the difference is on dependent variable. For ANOVA, we have, let's call it a same or similar variable or outcome variable. It's similar because it is just performance or just income, only that. But in that variable has different levels. So our case was just performance, but that performance has pre-mean and the post-mean. All right. So it's just mean of students' performance before, let's say, intervention, and the mean of student of student score after intervention. So both pre and post are scores under the performance, and that performance just same or similar variable. But it is different to MANOVA, because here performance just having one, let's say you can just consider a pre-test only or a post-test only or just a test, and it's just one performance. It's one variable, and another variable is different from performance, just income. Okay, you may also consider age, like, all right, as long as it is continuous data. All right, so I hope you understand this. Now let's go start our another version of ANOVA, which is multivariate analysis of variance. Okay, so here we have a chunk. We can start with just MANOVA, and we will see MANCOVA. All right, so we need to load our data. I have new data here in CSV form. Can import it, and when done, I can import it here, right? It has 73 observation and 9 variables. So we have our dependent variable. You have performance, student performance, and income, their parents' income, let's say in dollar or in francs or CFA or whatever, or euro or pounds. And the have variables: school name, gender, accommodation, grade, school type, as we had before. Okay, all right, so let's call it MANOVA result, and the formula is just as we compute ANOVA, because this is just a version ANOVA, then LM or linear model, and combine our dependent variable, cbind, which and which, combine performance and income. All right, and then alongside our dependent variable, let's just use gender, and then after need to put our data. Our data is new, just data, new file. Then after you can just use type 3. All right, we have here excess of parentheses, can delete it. All right, this, so you can run it, and here we get a result. We can print it, and see what we get. Here we are. All right, we have type 3 MANOVA result, Variance test statistic, degrees of freedom test statistics, approximation F value, degrees of freedom, and p value here. right? Intercept is very high statistical significant, and the gender is high statistical significant. What does this mean? This means combining performance and income. Gender makes effect, or gender is statistically significant different, all right? But we don't have any direction. To have a direction, which one among female and male is better, let's say has a high performance according to their parents' income, we can just come here and use descriptive statistics, which data is data new, pipe it, and group by our variable is a group is a gender, yes, and pipe this what, and summarize what. Let's mean performance equal to just mean of performance. Again, mean income equals mean of income. All right. You can also check standard deviation and the sample size, etc. But I think mean will be enough for this purpose. Okay, run it. We have the script statistics here. And we can see female has 33% in mean performance, and their parents earn about $3,400 income, and male got 43% in performance, and their parents earn about $4,300. So you can see male has performance has high mean in performance and high mean in their parents' income. So it means the statistical significance here we got, we can again print a result here. This one, the direction is along to male student. So it shows that the male and the female students are different when combining performance and their parents' income. And the favor is on male students. All right, we will also see in next episode how to compute post hoc tests such as Turkey and the effect size. But for just descriptive statistics, you can see the direction. All right, so this is how we calculate MANOVA. Let's go to MANCOVA. Let's call it MANCOVA results. And I hope you remember how we computed MANCOVA. Same thing here. Let's say we want to see one of dependent variable as covariate. Let's say income is a covariate of performance. we can bring it here, add on independent variable side. Here we are, and we don't need to bind. We just have performance on dependent variable side. Okay, now we can run this code and get it. Then let's print its results. Here, all right, you see different things. Intercept makes difference, but gender here doesn't make a difference. Only income make difference. What does this mean? You remember before using MANOVA, we got a gender statistical significant difference. But here using MANOVA, we don't get this difference. What does covariate mean in this case of MANOVA? Covariate doesn't mean neglecting that variable. Covariate means consider that variable as the effect on both dependent variable and independent variable. You control it, but you consider it. You control it to not mix with other dependent variable, but you consider its effect on both dependent and independent variable. So that's why MANOVA provide reliable results, and it gives you detail on effect of our independent variable on another dependent variable when checking effect on dependent variable separately. Let's say here, when considering a gender, male and female, on performance here, we don't get any statistical significance. But on income, the apparent income, it makes statistical significance. This means that the more effect is coming from the parents' income, it means the more parents get more income, the more effect on their student performance, more than gender does itself. It means that the difference between female and male in performance is more accelerated by their parents' income rather than just nature of students or gender of students. All right, I hope guys you got it, and you got the code to perform it. You can continuously perform this analysis, move around in any data and see how to interpret it. Otherwise, we will see each other in next episode when we are talking about exploring further these statistical significance. We're using Taki post hoc test and effect size.